Okay, so let's have a look what we have inside.
Dmitry,
Yeah.
one question. If it's possible to
Yeah.
switch to bigger screen, this picture.
Just exactly.
Okay, thank you.
Should be working right now. Okay. So in principle, I've put myself into the spotlight, so I think it works. Yeah. So for you, because unfortunately I'm not able to see it. Spencer, could you give me some feedback?
Yeah, we see the big picture of the case. Okay.
Okay, good. Yeah, because it doesn't work for me, so I have to work with a small. All right. Anyway, okay. So this is basically how our experimental systems typically look like. So they're supplied in such an aluminum case, which is also quite handy and practical for schools. Also, it can be easily taken away, and even experiments can be performed outside. So because the system can also be thought of as a completely grid independent. And why is that so? I will demonstrate to you right now. Okay, so let's have a look on the content. So as typically, we also have our base unit, yeah, so which is also kind of a heart of our system, where we also can plug our modules. And because most of our components have such a modular type, so they can be easily plugged and unplugged from the base unit, and can be also utilized later. So when I was saying that this system stays a little bit off the side from our typical product, is because we actually have two of such base units. So where the small one is typically used for the kids, and the large one is used for the high school students and school students. Okay. So yeah, we also have, as you can see, also lots and lots of modules inside, which we also cover just in a second. Okay. So as I mentioned, it's also a combination of pretty much all sorts of the renewables just in one single case, meaning that we also have, for example, here our wind turbine with different rotors, different rotor blades, so that the students can also play with them. Yeah, so with understand how changing one of the parameters influence on the total performance of the system. We also have 3 different solar cells. So namely a small one, a large one, also a larger one, and a large one. So they also are different in terms of the power output, in particular, so the current output and the voltage, of course. Yeah. So because this one is, for example, a connection of 3 different solar cells, single cells in a series. It does look like in a series. In this one is 2 cells which are connected in parallel. So that we have, so that we also have our current output higher due to the parallel connection of the cells, and we also have a large solar module, which we also use, for example, for producing a green hydrogen, which I also demonstrate to you later on. So as I mentioned, this system is completely independent. So we also have a wind generator, which we also use with our rotors, and there's also a hand generator in this case, which is mostly used for some primary level experiments, and we also have our water turbine. So that the students can also understand some basic hydropower So how it works, how the mechanical energy is also being converted into the electricity. So in this case, it's a Pelton type turbine, exactly. So which is sort of a reactive impulse turbine. It's also relatively safe to use in a class. So because it's just can be used with either a couple of bubbles, or also can be connected to the tap and to be run in the class as well. And so, as I also mentioned, we also have a reversible fuel cell, which can both be used as an electrolyzer and a fuel cell itself, which I will also demonstrate to you in a couple of minutes. And some other modules which are typically used as a consumer. So like, for example, this couple of LED modules, light emitting diodes. So a stand for our wind turbine, so that we can also adjust our turbine, so that we can also understand how changing of the direction of wind influence on the system performance. And so, yeah, and a couple of more modules also, which are also acting as a consumer mostly. Also for the energy storage, we have our supercapacitor, so that students can also understand the difference between a primary energy storage device, which is in this fact is a capacitor, and the secondary energy device, which is a fuel cell. Also a power module, which can also represent our conventional power plant, which we also need for our wind generator. And as I mentioned, so that we can also perform some quantitative experiments, we also have our so-called AV module, which is also able to measure simultaneously current and the voltage. Okay, good. All right, so let me just start with some basics, I guess. So we'll start with some experiments which are, in fact, oriented mostly for the kids. And then we'll also progress in the difficulty with time. Okay. So I guess we will just simply try to make something like this. I'll put the case aside. So I also have a little bit more space to play with. Okay, so yeah, as I already mentioned, that we also have two types of experiments. So that we also have experiments designed for the kids, and we also have some experiments designed for these high school students. So pupils in this case, they will mostly understand some phenomenological connection. So they don't need to know at the educational level, so how in fact it's transformed. They only need to know that it's transformed. Yeah? So meaning that we can start with some basics, like using a hand generator. And by rotating a hand generator, we also generate some electricity, and therefore our motor, and in this case our propeller, starts to rotate. And yeah, so basically how electricity is working. However, I mean, it might look it might look really basic, but even this hand generator can be also used for more complex routines, and it can be in fact used also to power up our wind generator, creating a grid-independent experimental system as well, so that we can, in fact, also do something like this. So we can power up our wind generator with our hand generator. And then use it to power up some consumer, let's say. Oops. Oh no, I guess it should be. Oh yeah, and it should be working. So yeah, in this case, I mean, even with the simplest experiment, we can create also completely independent, grid-independent system. And of course, we also have more complex experiments. So this I will just briefly demonstrate to you how the basic base unit can be used with the connection with our modules, and we can also do more complex experiments, as I mentioned, like with our solar cell, for example. So we'll just take a solar cell, take this one. Our AD module. And the potentiometer. Okay. Okay, so it works already. And just by using this relatively simple setup, we can also find a filling factor of our solar cell, meaning that we can also calculate the efficiency of the system. So all we need to do is just adjust our potentiometer. Okay, so it seems that I'm not getting enough sun. So I may need to use some extra lighting module, which is also included. So, and this lighting module can also be placed right on top of our solar cell, and we will do just fine. Yeah. So in this case, we can, as I mentioned, so by using potentiometer, we can also adjust, so gradually adjust the resistance, notice all of the values, and then by applying some, well, the relatively, once again, relatively simple math, we can calculate the efficiency of our solar cell, and also notice how it's effective relative to its nominal efficiency. Yeah, because so the stated efficiency of the polycrystalline or a single crystalline silicon solar cells is roughly 20% at this moment. However, the real efficiency is even lower than this value, because of course, so they also don't work 24/7. And yeah, so typically the efficiency is approximately a quarter of the stated value. Okay, so we can also do some other experiments. We can also understand how, so what happens if we shade our solar cell. So we can also do some partial shading. We can also see how it changes compared to the unshaded compared to the unshaded cell. Yeah. So we can, meaning that the students can also understand that sometimes when a solar cell is, for example, completely shaded, it in fact acts as a diode. So meaning that it doesn't let a current go, for example, in this way. Yeah, so we also have to do a bypass. So that these parameters are also quite important while designing your own solar cell setup. Okay. So another experiment is that they can also understand an influence of the initial light. Yeah, so how it's impact. So the importance of it. So therefore there is also this sun level, which also allows us to adjust. So roughly adjust a position of our solar cell relative to the incident light source, or this it can be either a sun or it can be some incandescent lamp. And the students can also understand how does the efficiency of the system changes with in a relation of the incident light. Okay. So yeah, these are some of the basic experiments with the solar power, which can be easily performed. So now we will move to the wind. And as I mentioned, we have this wind generator, which we also need to use. Just briefly. So yeah, and with the wind we can also, of course, find the total efficiency of the system. We can also find some basic connections about changing the number of blades or a rotor type will influence on our total system performance. And we can do it also both qualitative and quantitative, of course. So that we can also measure the voltage, we can also measure current at the same time. Okay. And in this case, as I mentioned, we can also do several types of the experiments. So first of all, we can just determine the IV characteristics of our wind turbine. So find the maximum power, which condition we also need to create a maximum power output. We can also adjust a position of the wind turbine relative, well, or wind relative to the wind turbine, yeah, so by just quickly adjusting it over here and also finding the optimized position of the wind turbine. And as I also mentioned, we can also easily swap rotors. And we can, for example, install right now this one with the 4 blades, and even if you have a look, they have a different geometry. So for example, this one has a so-called optimized geometry. Yeah, so that the rotor blade is specifically designed, while this one is just a simple flat profile. So something like a first generation windmills used to have. So yeah, we can also do the same for this rotor. And even if we do a quick comparison right now, I can already say that this type of rotor is approximately 30% less effective than the optimized. So with the optimized profile. And of course, we have lots of other rotors over here. So we also have with a different pitch angle or an angle, which is also sort of displays the difference between angle of attack and the profile of the blade itself. So that the students can also see lots and lots of variation, and they can also clearly determine what kind of system is the most effective and is also being used right now in a real scaled wind turbines. Okay. So yeah, another sort of energy that they so that the students can also work with is of course also hydro power. So it's a bit tricky to demonstrate for me right now because I have absolutely no water whatsoever in the over here, but yeah, I can also do just a quick mechanical so experimental conversion of the mechanical energy into the electricity, because basically this is how it works. So that we have also our generator, and while rotating our turbine, yeah, so we also generate some electricity, which is also being transferred to our propeller, which also starts to rotate. And in this case, students can also play with a basically with the water flux, so or how the changing of the water flux also influence on the efficiency. So more water, more electricity in this case. Yeah. Or while using, for example, the two water reservoirs, they can also understand how the height difference. So what actually role plays the height difference? So how much pressure it does create? Also how it limits or increases our water flux, and therefore how it also influences on the amount of the generated energy. Okay, that's also one of the energy types that we can also do with our case. And as I also mentioned, that we also have our fuel cell, a reversible fuel cell, which we can also use so this one is a reversible fuel cell, meaning it's both an electrolyzer and a fuel cell, so it can be used as both devices, and it's a PEM fuel cell, where the PEM stays either for a proton exchange membrane or a polymer electrolyte membrane. So, and in this particular case, we can also perform a couple of experiments with this. So we can either use our solar cell the generation of energy, and in this case, we also replicate a process of the production of the so-called green hydrogen, meaning that our energy is also being supplied from the renewable energy source. Or we can also replicate the process of creating gray hydrogen, which I also try to do right now. So basically what we need to do is just to add some water. Into both of the tanks. And then we need to apply some electricity, of course, to it. So a typical single cell electrolyzer needs around 1.2 volts to start the electrolysis process. So we will first try to do it with our solar cell and see whether it works or not. It typically works. I mean, it always works. I'm not sure whether it's going to be working right now or not, because, well, as usually we are also in Dresden, and today we're also not really happy with the sun or weather itself. So let me see whether it will be working. And if it doesn't, I have my large lamp over here. Which we can use. Oh yeah, and okay, so now it works. You probably can see some bubbles going up, and so meaning that water is also being pushed out of the water containers into the upper one. So, and we also generate both hydrogen and oxygen, and if we wait long enough, we will also see so that there will be around 2-to-1 ratio in the hydrogen tank to the oxygen tank. Yeah, because we also generate twice as much as hydrogen as an oxygen. Okay, so this is also a process of generation of the green hydrogen. Yeah. And another opportunity is also that we can do this process, and we can even speed it up a little bit by taking our base unit and our power module, which also represents the conventional power plant. And adjusting and optimizing all of the parameters. So that we can also do some qualitative experiments. Like, for example, we can also determine the efficiency of the electrolyzer. We can also make an IV curve out of it. And basically, we can also see how effective our system is compared to the theoretical efficiency. So should be also over here. Let's see. It should be working. So once again, if we wait just a little bit, or in this case around several minutes, we will also see a hydrogen being generated, which we can also later on utilize in the same cell. And so we can also power up, for example, so which we can also convert to the electricity, and for example, we can also power up our electric vehicle module by installing our fuel cell onto the stand, and yeah, well, using it as a fuel. So yeah. Okay, so yeah, it works. At the same time, I'll just leave it run. And if you have any questions, I think right now will be the time for them. Okay, so let me switch my camera once again. Okay, and hello again. So if you guys have any questions, I will be glad to hear them and try to answer them.
Kao što je rekao Dmitri, ako imate kako pitanje, slobodno. Dok se ne napuni vodik pa da se malo provozamo s autom.
Okay, I'm looking in the chat right now. I don't see anything in the chat as well. Okay, so I'll probably just sum things up, and so yeah. So what you have seen today is our experimental system designed for teaching renewable energies, which has several of them in such a case, and it can be used for teaching both the primary level students and the secondary level students, and up to the high school level, and sometimes even more. Oh, okay. It's a
Dmitri?
Yep.
Is it possible that we see that the car is running on the hydrogen?
I actually switched it off, so unfortunately I switched off the fuel cell, so it needs some time. Well, let me see. Let me try to switch it on if it works. Okay, yeah. So because this reversible fuel cell needs some time, so typically it's between 5 to 6 minutes. So that we need. Okay, so what kind of water can we use? So we usually use just a regular distilled water. So yeah, There is also some in the case, of course, always supplied. So it's a typically either 100 milliliters or 200 milliliters bottle. So that you also have everything right from the start, and then of course can be always easily bought, or even from the typical gas station. A tap water is, I mean, it's not advised to be used for the fuel cell, of course not. Because in this case, the membrane can start degrading. I don't have it in mind, but I think so. The typical conductivity should be less than 17 microsiemens or 19, something like this. So yeah, otherwise the membrane can be degrading. So, and if we want to, if we want our fuel cell to work for a while, and we always want it to work for a while, well, then it should be used only with a distilled water. And could you also please, Mr. Zdenko, could you just explain your question a little bit? So about junction schemes. If the question was and is about whether do we provide an experimental setups and so on, then yes, of course, that I also forgot to mention it. So all of our experimental systems are also being supplied with two different manuals. So where one is for the student and the second one is for the teachers. So and for the teachers, a teacher's manual always also has all of them answers, all of the experimental results, and so on.
Okay, Dmitry, if there is no question, I think we are finished for today. Thank you very much for a great presentation. I enjoyed. I hope everybody, and we learn many things.
So yes, there is one more question. So about how many experiments can we make? So with this said, I will once again show you my presentation just quickly. So here you can see all of the experiments which can be done also for the primary level, and so we have 27 of them. So they're mostly phenomenological, meaning so that it's really a dependence on the physical event and a result. Yeah, but it does the job quite well. And so there is also well, more than 21. I mean, 21 experiment for the secondary level. But as you can see, some of the experiments are also subdivided into the sub-experiment. Let's say like this. So yeah, it's on average 20 in this case. Okay. Okay, yeah. Let me quickly check. I might be able to run it up right now. So because yeah, I've generated some of them.
Yeah, everybody want to see.
Let me see. I hope it works. No, it's not enough yet. Looks like not really. Ah, no. So basically, yeah, it works, it runs, as you can see. And of course, the students can also understand it. How different sorts of the energy storage devices, whether they're more effective or less effective, because we can also perform the same operation with our capacitor. I'm not sure whether it's charged or not. So let's see. And also see so that the power output from the capacitor is in fact way higher. Okay, so it's discharged, almost discharged. Yeah. But if we charge it, so we can also see that the power output from the capacitor is larger, so that the car will also run faster than while running on the fuel cell. So yeah, wheels are turning. Yes, exactly.
Okay, Dmitry. Thank you very much once again. I think it was very nice lecture and presentation. And
okay, so thank you very much as well. So on behalf of the leXsolar, I wish you a good day and yeah, all the best.
Okay, thank you. I will say a few words on Croatian. Zahvaljujem se još jedanput svim sudionicima webinara. Postali smo izgleda sad regionalni webinar već jer imamo sudionike iz Hrvatske, Bosne i Hercegovine, Srbije, tako da pozdravljam sve još jedanput i zahvaljujem svima na sudjelovanju. Nadam se da ste vi nešto novo naučili, zanimljivo kao i ja. Tako da ukoliko su vam leXsolar proizvodi zanimljivi, naravno da postoji mogućnost prezentacije u školama, to radimo redovito. Što se tiče tih setova, znači ja imam u firmi, firma ima, imamo fotonaponsku, set fotonaponski, imamo energiju vjetra i termalnu energiju, tako da ukoliko neko želi, neka škola, bilo ko uživo nekakvu prezentaciju i to nije sporno, to ćemo napraviti, čak opcija postoji da u dogovoru sa profesorima ko radi vježbe nekakve iz obnovljivih izvora energije da im posudimo na 10-15 dana da malo sa učenicima rade, to je sve besplatno, tako da ne bi bilo zabune. I to je to. Još jednom ponavljam, za potvrde na moj mail koji sam stavio u chatu, pošaljite podatke svoje, podatke od škole, ustanove u kojoj radite i u nekakvom brzom roku će vam poslati te potvrde. Danas sigurno neće biti tako da evo. Ali uglavnom, evo, zahvaljujem još jedanput i želim vam ugodan dan. Lijepi pozdrav.
Yeah. Thank you very much. And Zdenko, if you can either contact us, also if you want to receive some examples, yeah, or you can an email you can find over here, or you can also contact BELMET, and they will probably readdress it either to us, or if they can do it, they can also send it also to you.
Yeah.
So yeah, I hope it also helps you.
Yeah, thank you, Dmitry. Okay, no problem. If you have some question and i ako ima neko nekako pitanje, slobodno se obratite nama ili leXsolaru, riješit ćemo sve, tako da. To je to, još jednom vam se zahvaljujem i lijepi pozdrav.
Pozdrav, bye.